As you can see, it does say that we're going to be looking at solving equations using something called the change of base property, and we'll talk about what that property here is in a little while. But before we do that, if you look at the top of your paper, you'll notice that they give us 4 different exponential equations. The question is, what do all 4 of these have in common? Do you notice anything about those?
The exponent.
What about the exponent?
They're missing.
They're all
the variables.
Okay, so what I want you to do for number 1 is I want you to write down for me that all of these have an exponent of x. All of these have an exponent of x. All 4 of those equations that you were given have an exponent of x. That's what they have in common. So what we're going to be looking at today is how to solve equations like this. Now, what we're going to do on number 2 is we're going to rewrite each of these exponentials in the form of a log, which we did last week. You guys should be familiar with that and know how to do that already. So, for example, the first one, a, 2 to the x power equals 20. How do I write that in the form of a log? Log, what's the base going to be? 2. What's the argument or inside the parentheses going to be? 20, and it's going to equal to x. So all I'm doing right now is rewriting. Let's do the same thing for b. Let's take the exponential and rewrite it in the form of a log. So that becomes log with what base? 10 of what? 48 equals x. Good question. Do I have to put the 10, guys? No. Remember, if it doesn't have the 10, it's common log. It's understood to be a 10. The next one here. 0.8 to the x power equals 4. We'll write that as log with what base? 0.8 of 4 equals x. And of course, the last one, d, there would be the same thing. We have log with a base of 2.718 of 60 equals x. So this is just a little review of what we talked about last week, converting from an exponential to a log. Now, number 3 says, which of these 4 equations can now be solved directly using a calculator? In other words, only one of these we can actually put in the calculator. Which one is B? Why can we put B in the calculator? That's right, because the calculator has base 10. That's what it works, all right? So go ahead and put that in your calculator for me. Let's see what we get. What is the log of 48? Remember, the base is already understood to be. What was that again? 1.124. Now, guys, keep in mind when you're writing your answers, the more decimals you put, the more accurate your answer is going to be. Okay? So just as many as you can. As a matter of fact, if you can write it as a fraction, I would prefer that you give me the fraction instead. Number 4 says, why are the other equations? How come we can't put the other ones in the calculator? That's right. So for number 4, the reason we can't put A, C, or D in the calculator is because they don't have a base of 10. The calculator only knows base of 10. Or at least our calculators. I'm sure there's more expensive calculators that can do that. And then what? So remember, it cannot do it. I want you to sound smart, but not too smart.
Yeah, I want to think that.
All right, so in summary here, a calculator can evaluate logarithms that have a base of 10. It cannot evaluate logs with bases such as a 2 or a 0.8, a 5, a 6. It can only work in bases of 10. Right?
Yeah.
Okay.
No.
All right, so if you take a look here, we're given 2 exponentials. 2 to the x power equals 20, and 0.8 to the x power equals 4. And we want to solve these equations. Now, the steps we're going to follow are over here on the left-hand side. Now, the other day we talked about undoing things are opposite. We all know the opposite of adding is subtracting. The opposite of multiplying is dividing. Opposite of squaring is square root. But we also talked about how to undo, or the opposite of exponent. And we said the opposite of the exponent was log. Okay? So what we're going to start off with is to solve this equation is we're going to take the log of both sides of the equation. In other words, we're going to have log of 2 to the x power, and that's going to equal to the log of 20. All I'm doing is taking the log of both sides. Then we're going to use a property that we talked about last week. And the property says that an exponent inside the log, referring to this exponent right here, an exponent inside the log can be changed to what? The exponent can be changed to, I think you're on the right track. I'm looking for the operation. There it is, multiplication. So we're going to change this to the x power. We're going to change that exponent to multiplication. In other words, log of 2 to the x power is now going to become 2 times the log of, not x, but 2. And of course, it's still going to equal to the log of 20. So all I did was change the exponent into multiplication. And we had that property last week that said we can do that. So the question is, why did I do that? Well, if you look closely at the equation I have there, the whole idea here is that we're solving for the x. Well, what are they doing to the x right now? They're multiplying it by what? Log of 2. So guess what? What's the opposite of multiplying by log of 2? Dividing. So what we're going to do is we're going to divide so we can solve for x. In other words, we're going to do log of 20 divided by the log of 2. Now notice how both of those logs I have there are working in basis of 10, meaning we can put that in the calculator. So put that in your calculator and let's see what we get. What is the log of 20 divided by the log of 2?
Does it matter like which one you convert?
Yes, yes it does. Remember, we're solving for x, so we're dividing by log of 2. So what is log of 20 divided by log of 2? And it is, and remember, if you can get a fraction, that's what I prefer. But if not, give me a decimal. Try and give me as many decimal places as you can. Okay, say that again. 4.3219, and so on and so on. So the more decimals you include, the more accurate your answer is going to end up being. So what we've just found is the solution to this equation. In other words, we've just found out what the exponent needs to be. 2 to the 4.321928 power, guess what that's going to equal? What does it say it's supposed to equal over here? 20. Let's check this just to make sure. We're going to have 2 to the 4.321928 power. Put that in your calculator. Let's see what we get. If we did our work correctly, it should be equal to a 20. Is that what it's equal to? Yes? Equal to 20. Now, I will tell you guys, depending on where you round your answers, in other words, if I put 2 to the 4.3 power, am I going to get exactly 20? Probably not, but I will get something pretty close. So this is why I say the more decimals you include, the more accurate your answer is going to be. Let's try the next one. It's going to work the same way. I want to know what is the x. I want to know what is x. So the way we do that is by taking the log of both sides. Here it is. I'm taking the log of both sides. Now I'm going to use the property that says I can change the exponent to multiplication. So this is now going to become x times the log of 0.8 is equal to the log of 4. And the reason we're changing it is so that we can solve for the x. I want to know what is x equal to. So to solve for x, we're going to need to divide. So what we're going to have is the log of 4 divided by the log of 0.8. Now notice how both of those logs I have there are in basis of 10. So we can put that in our calculator. So what is the log of 4 divided by log of 0.8? That is correct. So the more decimals you include, the more accurate your answer is. So we've just solved for x. We now know what the exponent needs to be, and it needs to be a negative 6.2125667. And we can just double check our work here real quick. 0.8 to the negative 6.212567 power should be exactly, or if not, pretty darn close to 4, depending on where you round your decimal. You guys with me? We're okay so far? All right, let's take a look at the next page then. Over on the next page, there's a couple of things that they want us to do. For each exponential equation, the first thing they're going to want us to do is rewrite in the form of a log, and we'll put that in box A. Then what they want us to do is solve the equation algebraically, which is what we did on the first page. And then we'll go ahead and use our calculator to come up with our final answer. All right, so here we go. Let's do those three things. For part A, we're going to take 6 to the x power is equal to 104 and write it in the form of a log. So here it is. The log, what's the base going to be? 6 of 104, and it's going to equal to x. So all I'm doing is rewriting. And we'll come back to that a little bit later. For right now, we're done with box A. Now I want to solve this equation for x. I want to do exactly what I did on the first page. So the way we did it was we took the log of both sides. So I've got log of 6 to the x power is equal to the log of 104. Then what we did was we used the property that says I can change the exponent to multiplication, which means now I end up with x times the log of 6, and it's still equal to the log of 104. I'm solving for x, and in order to solve for x, I'm going to need to divide by log of 6. So what I have is log of 104 divided by log of 6. And at this point, all I need to do is put that in the calculator and see what we get. So what is the log of 104 divided by log of 6? 2.592, and you fill in the rest. It's that real long decimal. So this would be our solution to this equation. And that's what the exponent needs to be in order to get the answer of 104. Okay, let's try number 2. Same exact thing. We're going to start off by rewriting in the form of a log. That's pretty easy. We've done that several times now. This is now going to become log with base 1.5 of 22 equals x. So we're done with that part of it. We'll talk about what that is in a little while. Now let's move on to part B, which is to solve the equation. And the way we solve the equation is by taking the log of both sides. So I got log of 1.5 to the x power is equal to the log of 22. Now I'm going to use that property that says multiplication. The exponent is the same thing as multiplication. So now I've got log of 1.5 is equal to the log of 22. And I am solving for x. So if I'm solving for x, I'm going to need to divide. So I'm going to take the log of 22 and divide it by the log of 1.5. All that's left for me to do now is put that in the calculator and see what you get. What do we get when we put that into the calculator? You got it. So that big, long, ugly decimal. That is what the exponent needs to be on the base 1.5 so that we end up with an answer of 22. All right, I'm going to do one more with you guys, and then I'm going to let you try one on your own. Number 3. Let's start by rewriting this. And if I rewrite it, that now becomes log base 8 of 1200 equals x. So I'm done with the first part. All I did was rewrite it. Now I'm going to solve for x. So what I'm going to need to do is take the log of both sides. So I'm going to take the log of 8 to the x power, and it's going to equal to the log of 1200. Now I'm going to use the property that says that the exponent is the same thing as multiplication, which means now I'm going to write it as x times the log of 8, and that's going to equal to the log of 1200. What I'm doing is I'm solving for x. So in order to solve for x, I'm going to need to divide. So we're going to take that log of 1200, and all we're going to do is divide it by the log of 8. So the question is, what do we get when we divide the log of 1200 divided by the log of 8? 3.04, 3.4096, and so on and so on. So you put as many decimals as you can. We're good? All right, I want you to try number 4 on your own for me. Do the same thing. For part A, you're going to rewrite in the form of a log. For part B, you're going to solve it. And for part C, go ahead and put it in your calculator and see what final answer we get. You guys are pretty quick. All right, so there's the first part. All we're doing is rewriting in the form of a log. From here, we're going to solve for x, which means the first thing you should have done is taken the log of both sides. That's the first part, taking the log of both sides. Then we're going to use the property that says that I can take the exponent, change it to multiplication, which means I now have this right here. And finally, since I'm solving for x, I'm going to need to divide. So we're going to take the log of 3.5. We're going to divide that by the log of 7. And you guys came up with what? And so on. So this would be our answer. 0.64379, so on, so on, so on. Pretty easy. Can we make it even easier? I hope so. Let's see if I can make it even easier for you. All right, so at this point, we've looked at 4 different examples. What I want to do now is take a look at all 4 of those examples. This is the same thing we just got through doing on all 4. Down here it says, for each of the solutions given above, look at the expression in the boxes. And I've highlighted those for you. That's what's in yellow. So what I want you to do is look here and here. Look here and here. Look here and here. We're looking for some kind of a relationship. Do you notice anything about what we see in these 2 boxes? Do you notice some kind of a pattern going on? What's that? The exponent is what? Divided by the base. All right. Anybody notice anything else? I think I kind of understood it. Anybody want to make it a little more quick? What?
By the log of argument. By the log of
Ah, there we go. All right. So notice what's in parentheses. That 104 is the numerator. Notice that the base is the denominator. Is that true for all 4 of these examples? Yes. Notice what's in parentheses is always in the numerator. What's our base is always in the denominator. That's important for us, guys. So, down here, where it says how were they related, I just want you to put down that our numerator is our argument, and our denominator is our base. Our numerator is the argument. The denominator is our base. And that's going to come in handy to help things speed things up. That thing you just noticed there, guys, that is called the change of base property. That is called the change of base property. So, when we have log base b of n, that's going to equal to what? What did we just say? Log of n divided by log of what? B, the base. Again, this is what we call the change of base property. We use that in several different ways. And we'll talk about how we use that here in a second. Alright, so with our calculator, we're going to use this change of base property to evaluate some expressions. Now remember, number 5, log base 8 of 32. Can I put that in the calculator?
Yes.
Well, yes and no. No, we cannot, because it doesn't have a base of 10. However, some calculators can. So, what we're going to need to do is rewrite it using our change of base property. So here it is. We're going to change this into this right here. Log of 32 divided by the log of 8. All I'm doing is using my change of base property. And the reason I'm doing that is so that I can put it in my calculator. So go ahead and do that for me. What is the log of 32 divided by the log of 8? Remember, I prefer a fraction if it's possible. What is the log of 32 divided by the log of 8? 5 over 3. And that is correct. 5 over 3. So in order to get that 5 over 3, we had to use our change of base property first. So let's go on to number 6. I want to know what is log base 7 of 1 over 49. Well, the first thing I got to do is change it. And we change it using that change of base property. So we're going to write this as log of 1 over 49 divided by the log of 7. So put that in your calculator to see what we get. -2, that is correct. Keep going, number 7. Let's rewrite that one as well. This is now going to become log of 512 divided by the log of 16. And the log of 512 divided by the log of 16 is, oh yeah, give me the fraction. 9 over 4. 9 over 4. 9 over 4. And then the last one, same idea. We'll use our change of base property, so that now becomes log 0.03125 divided by the log of 4. And what do you get when you divide those two things? Give me the fraction. -5 over 2. So number 8 should be -5 over 2. So again, in order to change these, or in order to get these, we had to change them using that change of base property. Okay, over on the next page, we're going to do the same thing, but this time, we're not going to put anything into our calculator. We're not going to solve for anything. All we're going to do is rewrite them so that we have a common log. So the first one, we got log base k of 2. So we're going to rewrite that using the change of base property. So that now becomes what? Log of 2 divided by log of k. That's it. That's all we're going to do with that. Just rewrite it. Look at number 10. Same thing. All we're going to do is rewrite it. So what's the numerator going to be? Log of x. The denominator is going to be log of 4. That's simple. 11. What's the numerator? Log of what? X plus 6. And the denominator is going to be log of, the denominator is 8. And then the last one, the numerator is going to be log of 1/2. The denominator is going to be log of x plus 2. That's it. So on this one, we were just rewriting. Nothing to solve, just rewrite. So we can use this property in order to graph these logarithmic functions. For example, right now we cannot go to our y equals and type in log base 2 of x, right? Right. We cannot do anything other than bases of 10. So we can get around that by using that change of base property. We can change log base 2 of x as log of x divided by log of 2, put that into y equals, and get its graph, which would be the same thing as the graph of log base 2 of x. So let's try that with a couple of these here. So number 13, I want to know, what does the graph of log base 2 of x plus 4 look like? Well, in order to see that graph, we're going to have to use our change of base property. So this is now going to become log of x plus 4 divided by the log of 2. So put that in your calculator. Let's see what we get. Put that in y equals. See what graph? We're looking at the graph. Put that. No intersection on this one. We're just graphing the log of x plus 4 divided by log of 2. And I want to see what the graph is going to look like. And the graph looks something like this here. Now listen to my question carefully, guys. Everybody listen to the question. This graph that I'm looking at here, is this the graph of log of x plus 4 divided by log of 2? Or is this the graph of log base 2 of x plus 4? Both. It's the same. It's both of them. That was a trick question. Okay? You're looking at the graph of both of these. Remember, we changed this log base 2 of x plus 4 as the log of x plus 4 divided by log of 2. So they are the same thing. Okay, let's go to the next one, number 14. I want to know what the graph of that looks like. But in order to see that graph, I'm going to have to use my change of base property. So we're going to change this as log of x minus 1 divided by log of 0.5. Put that in your calculator. Let's see what we get. And if we type this in correctly, the graph we should be getting looks something like this here. That's the graph of log base 0.5 of x minus 1. And we got one more graph to look at. It's a little bit trickier here. Number 15, we have f of x is equal to 2 times the log of log base 4 of x minus 3. So I want to know, what does that graph look like? Well, the first thing I got to do is rewrite this thing. The question is, how do I rewrite it? What's my numerator? Which one? I heard log of 2x and I heard log of x squared. And actually, okay, which one? 2x? The property says that multiplying is the same thing as, we did it earlier, actually we did it backwards earlier. We said the exponent was the same thing as multiplying. So if the exponent is the same thing as multiplying, multiplying is the same thing as exponent. So what am I going to write for my numerator then? Log of is this thing on? Huh? Nope. I heard it. Log of what? There it is. Log of x squared. Okay. Log of x squared. And actually there is an alternative, and I'll show you that here in a minute. That's the numerator. What about the denominator? What's going to go at the bottom? Remember, we're using a change of base property, guys. What goes at the bottom? Log of 4. Remember, we said the denominator was going to be our base. But what about the minus 3? We can't just Right? All right, so we'll put it on the outside, just like this here. Now, just real quick here, before we put that in our calculator, the numerator. We wrote the numerator as log of x squared. But what do we say the exponent was the same thing as? Multiplication. So couldn't I also write it as 2 log of x? Would it be the same thing? Of course, the denominator would still be log of 4 minus 3. So this would be an alternative way of writing what we have on. They mean the same thing. Okay? Huh? Yeah, you can do that too. So go ahead and put that in your calculator and let's see what we get. Let's see what the graph is going to look like. Let's see what the graph looks like. Nope. Be careful, guys. Be very careful how you typing it in. You may need some extra parentheses unless you're using that alpha y equals to type it incorrectly. Here's what we should be getting. If you type it incorrectly, the graph we should be getting looks something like this right here. If you didn't get that, you might want to recheck how you're typing it in. That is the graph we should be getting. Yeah, and this has to do with how you're typing it in, so just double check it. All right, we got one last thing to look at. There's 2 examples of it, and that's inequalities. Inequalities. Now, the inequalities that we run into earlier, last week and right before spring break, we said we can work with these inequalities. And the easiest way to solve these inequalities was to use our calculator. And what we did was we took the left side of the inequality, put it into y1. We took the right side of the inequality and put it into y2. But we have a problem here. I want to put log base 3 of x plus 5 into y1. Can I do that? No. No. Why? Because we have to have a base of 10. So what are we going to do? We're going to use that change of base property and change it. So what we're going to do in y1 is we're going to do log of x plus 5 divided by log of 3. We're using that change of base property. In y2, we're going to type in the right side of the inequality, which is just a 2. Then we're going to stick that in the calculator and see what we get. So go ahead and do that for me. Go to y equals and put both of those in for me. Now remember, when you get this graph, you're going to see 2 things. You're going to see the graph of a log, but you're also going to see a horizontal line. And that horizontal line represents the 2 that we typed into y2. What we want to know is what is that point of intersection, because it's important for us. It's part of our solution. So make sure you find that point of intersection by going to second trace, number 5, enter, enter, enter. And we should end up with something that looks like this here. Remember, I said that point of intersection was important. That's this point right here. And that point of intersection was at 4, 2. So part of my solution over here is x. And right now we're looking for the x value, so I'm concerned with just the 4, not the 2. Now let's go back to the inequality and see what it says. We want to know when is this function right here less than a 2. In other words, when are the y values going to be less than a 2? Well, that's what this horizontal line is for. Remember, that represents 2. So anything below this line would represent y values that are less than a 2. So that's the part of the graph that I'm concerned with. So if you look at this green part of the graph that I've just outlined, what kind of x values does that part of the graph have? X's that are less than 4. Do you all agree with that? All the x values are less than a 4. But there's one little detail that we're missing. Anybody see it? What? Say it. I think you were saying it. What about it? Do we have one? Is there asymptote on this graph here? Yes, there is. It's a vertical asymptote. There's a line that we're getting really close to but not touching. Anybody know what it is? Nope. That's pretty close. Right. -5. -5 is our vertical asymptote. So what we're going to come over here and do, we're going to add to this the fact that we can't go past that -5. In other words, the solutions are going to be all the x values that are between a -5 and a +4. Anything between a -5 and a +4 would end up with y values that are less than a 2. Let's go ahead and do the same thing for number 17 here. 17. I want to graph this. Of course, I've got to use my change of base property. So let's see. This is now going to become log x minus 2 divided by log of 2. And let's graph this one and see what happens. Remember, guys, we're looking for that point of intersection. It's important for us. It's part of our solution. All right, this is the graph we should be getting. Again, we're looking for that point of intersection, which this time is at 6, 2. That's the point of intersection. Now remember, this time the inequality says, when is the function greater than or equal to 2? In other words, when are the y values greater than or equal to 2? Well, that's going to occur above the line. I'm referring to this part of the graph right here. Everything above that line would have y values that are greater than or equal to a 2. So, what kind of x values do we have on that green portion of the graph? X's are what? Greater than or equal to a 6. Therefore, my solution here is x is greater than or equal to 6. It's just going to continue going out to the right forever and ever and ever and ever. All right, any questions? All right, that takes us through you have the power,